Good morning, science fans. Welcome to another day of science. It is Wednesday, November 11th. Here we are. If you're wondering if there's something different about me, yes, I did, in fact, get new glasses. You're right. Yep, not a haircut, new glasses. All right, let's check out the Wednesday folder. Three things to do. Watch the walkthrough video. Read the page titled Proving Pangea Part 2. Up here we had Proving Pangea Part 1. Anytime there's a Part 1, it means Part 2 is coming. So here's Part 2 today. And then complete the assessment titled Proof of Pangea Quick Check. Learning target. I can describe the two pieces of proof that have proved the existence of Pangea. Performance task. Students will investigate the mid-ocean ridges and ages of rocks on the ocean floor. And success criteria. I will be successful when I've answered 4 out of 5 questions correctly on the quick check. That should say 3 out of 4. I'll change that. Don't worry, gang. So let's jump into the Wednesday folder. Here's the Proving Pangea Part 2 page. A reminder, scheduling note, there will be a Google Meet Thursday at 11:30. Please plan to attend. I will post that link in here tomorrow. All right, so yesterday we looked at the evidence that Alfred Wegener had to support his idea of Pangea, a supercontinent that contained all the land on the Earth about 200 million years ago. The scientific community was skeptical of this idea at first, but all the evidence that Wegener was able to gather made them more likely to believe his ideas of Pangea. However, he was still missing one thing. He was missing proof. Today, that is what we will look at. We'll look at the proof that actually helped prove that Pangea existed and that the plates were moving. So there's a slideshow below that I'm going to go through here with you. We'll read each slide carefully, look at the pictures, and then when you're done, you can use the information to complete the quick check. All right. Whoop. Here we go, Proving Pangea Part 2. So we said yesterday, we looked at Alfred Wegener's idea of the supercontinent of Pangea containing all the land on the Earth. The scientific community was a little skeptical of his idea because he didn't have any evidence of its existence. So then he spent 3 years gathering evidence and presented that to the scientific community. They were then impressed with his idea, but he was still missing one thing. We'll see what that is, the proof. The evidence, remember, the continents fit together like a puzzle. 1, 2, the fossil evidence from around the world where land animals were living on, land animal fossils were found on continents that are separated by ocean. 3, the rock structures and ages, same types of rocks were found separated by the Atlantic Ocean in North America and Africa. And then 4, the glacial evidence. He found evidence of glaciers on land and continents that now have very warm climates, and even during the last ice age could not have had glaciers on them. So those are 4 pieces of evidence. They were impressed, but he was still missing one thing. He was missing the proof. Even though Wegener had lots of evidence, he didn't actually have any proof that the plates were moving. There was nothing that he could point to show scientists that this is what is moving the plates. He couldn't say, like, see, here's all my evidence, and I can show where the plates are moving. So unfortunately, Alfred Wegener died before the proof was discovered. R.I.P. Wegener. Now, after World War II, in the 1950s, scientists started to map the ocean floor. Our technology improved. The technology that we had during World War II to try to find German submarines helped us to map the ocean floor. And as we were doing that, we noticed something. A large mountain range that extended the entire length of the Atlantic Ocean. There's a huge mountain range, and people are like, what is this? We now call this the Mid-Ocean Ridge or the Mid-Atlantic Ridge. Further study of the Mid-Ocean Ridge led to the big breakthrough that provided the proof that the plates were moving. So if you go to the middle of the Atlantic Ocean, the bottom of the ocean floor, you will find a sort of a little ridge, a mountain range, a rise, whatever you want to call it, the entire length of the Atlantic Ocean and in a few other ocean spots around the world. But here's what's going on at the Mid-Atlantic Ridge and other mid-ocean ridges. Magma, it's called magma when it's inside the Earth. Magma is coming up from the asthenosphere. Remember, that's a layer that we've talked about. It's coming up from the asthenosphere. There's a giant crack along the bottom of the Atlantic Ocean, And when that magma comes up, it pushes the old crust out of the way, and the plates are then moving slowly away from each other at this spot. This is called a divergent plate boundary. We'll look more at this a little bit later. But new magma comes up, it builds up a little bit, piles up a little bit, and pushes the old crust out of the way. Remember, the asthenosphere is kind of like silly putty. So the plates are actually floating on the asthenosphere, and so it can move very, very slowly. And so the plates move ever so slowly away from each other on the asthenosphere. This is an area that we could point to, and had Alfred Wegener still been alive, we could have pointed to and said, look, this is where the plates are moving. This map shows the Mid-Atlantic Ridge right here, this red stitch mark up and down the Atlantic Ocean, but you'll see there are other mid-ocean ridges elsewhere. Anytime we see these red stitch marks, this is where new ocean floor is being created. So this is a huge breakthrough. It shows this is where floor is being created, and this is a spot that we can look at and say, yes, the plates are moving. This discovery and study of the mid-ocean ridge led scientists to realize that there are areas on the ocean floor where moving Earth's giant plates. There was one other discovery that helped definitively prove that the plates had moved, and it came from studying the ages of rocks on the ocean floor. What we notice is that rocks that are farther from the mid-ocean ridges are older than rocks that are closer to the mid-ocean ridges, proving once and for all that the plates are moving. So here's how this proved it. Let's take a look at the next picture. This shows how old the rocks are on the ocean floor. So dark red stuff, those are the youngest rocks. Then as it gets lighter red, those are a little bit older, and then the bluest rocks are the oldest rocks. So right here, let's look at the Mid-Atlantic Ridge right here, right up and down the Atlantic Ocean. You'll see there's a band of bright red. These are very young rocks right at the Mid-Atlantic Ridge. The further we go, the older the rocks are. So as the magma comes up and pushes the crust away, the older crust gets pushed out of the way, new crust is coming up. And so like here, way over here by North America and way over here by Africa, these are the oldest rocks because this is where Pangaea started to break apart first. This is the first area of spreading that took place on Pangaea. You can see other spots where there's younger rocks and older rocks on the ocean floor, but this study of the age of rocks showed that, hey, the plates are moving, and we can look at the ages of rocks to show it. So these two pieces of proof, the mid-ocean ridge and the study of the ages of rocks, this proved that the plates are moving. Unfortunately, Alfred Wegener was dead at this point in time, but he was vindicated. That means he was proven to be correct by all this evidence and all this proof that had been gathered. And so this is how we can say 100% for sure that Pangaea used to be a thing, all the land and the earth was connected, and that the plates have been broken apart and have been moving away from each other and moving around ever since. So that crazy idea that Alfred Wegener came up with ended up being correct. Crazy. But that's how science works. You find some evidence, you find some proof, you keep building your case. He didn't quit, didn't give up. So what you guys need to do now is use the information here and then go to the Proof of Pangaea quick check. There's just a couple multiple choice, maybe a couple true or false questions in there. But answer those. Make sure, if you have not already, I also posted something in the Lunch and Learn group, so make sure you do that. And then there's a Google Meet Thursday at 11:30 a.m., and I will see you all there. Have a wonderful day. Bobolek out.